So we are doing procedure C. Yeah, we can lower it a little bit. We don't have a professional cameraman. So we've got procedure C. We're doing 3 of them this time. We're going to, again, try and do them as side by side as we can. If we look at, there's 3 test tubes, A, B, and C. Test tube A is just 6 molar hydrochloric acid, right? So it's a fairly concentrated acid. B will be 5 milliliters of water that's already in there. You probably can't really see that there. And then Mrs. Higgins is going to add 5 more milliliters of HCl. And then C is 2.5 milliliters of HCl and 7.5 milliliters of water. So I only put 2.5 milliliters. I messed up when I was doing this one. I only did 2.5 milliliters of water.
That's what you want, right?
No, I think
No,
C.
yeah, you're right. You're
Yeah.
right.
C should be 2.5. So I didn't read the directions. I just started pouring and mixing and whatever.
Right, so
But since I'm actually reading the directions now,
well, we didn't because we already did all this one.
we did already do all this on Friday. So Ms. Higgins is going to fix that mistake for me. But so we've got these 3 different test tubes with the same chemicals in them, but different. And they're all going to be 10 total milliliters, but 2 of them have different amounts of water in them, and 1 of them has no water other than what's already in the HCl and stuff. So again, kind of focused on what's the factor that's different there. And then we will add to that magnesium metal. All right, so this is magnesium metal. And if you remember from our single replacement reaction stuff, active metals like magnesium and zinc and lithium and sodium and all the kind of things all will react with acid. So we're going to see a reaction with the acid. And when we go to do that, we'll jump to the document camera and try and be up close so we can see what's going on there. Again, we'll want to focus on what's different with those, especially in terms of like rate stuff. And we don't need to watch her finish filling that test tube, so we'll go ahead and jump to the doc camera. So we've got our 3 test tubes set up here. I think you can see them pretty well. 10 mil, nope, yep. Wrong side. Nope. 10 milliliters right here, 5 and 5, only 2.5 of HCl. You can kind of see they're all basically the same total volume there. We've got scupulas with our magnesium, and best we can, we're going to try and put them all in there at the same time. Ready? 3, 2, 1, go. You can see how those guys are reacting. I'll pull each one up a little closer, jostle it. Again, we're expecting them all to react, right? Because acids will react with active metals, and magnesium is certainly an active metal. Well, let's see. Yep. So what we're looking for is the differences in them. If we look, that 10 milliliter one appears to be done, right? The one that was all HCl. I'm not seeing it react anymore. I don't see any magnesium in it anymore, right? That test tube's, well, the magnesium's still there, right? It's just Mg+2 now. It's a little redox reaction.
It's like the 5 is done. 5 and 5. You kind of still see a couple pieces in there.
Can't imagine what's different about those. World's hardest lab.
Science.
I hear the word still out on science. So that is procedure B. No, C. C. Something C. Yep.
I see. Okay, procedure D here. We are going to take our 2 pieces of aluminum foil, and we're going to do this side by side. So I know on the instructions it says, okay, do this to it, and then it says, okay, observe what's happening, now do this. We're actually going to do 2 that are going to be side by side. So with each one of those, we're going to take a scoop, just a scoop, doesn't really matter how much, of some copper 2 sulfate. Remember the blue stuff. And because it's still solid, it's not really going to move its molecules around until we wet it. So we're going to add some distilled water to it. And ooh, pretty.
All right, remember that idea in collision theory? They have to be able to collide. So solids just kind of sit there and don't move a whole lot. So we want to make sure that they're moving so they get a chance to react.
Okay, so you can kind of see they're like, is it a color change because it's wet? Now we're going to take let's do this one here. Just figure out which one on the screen.
I'll point the glass
the
stirring
one
rod.
glass stirring I was pointing at, and we're going to add some sodium chloride to it. Maybe you guys will notice a little something different. I have to mix it around.
Yep. So to clarify, this is a single replacement reaction. We'll just let you observe for a second. Look at that coolness. Right, when we think back to our evidence of a chemical reaction, right? I don't know if you can see the steam there, but it's actually hot enough that it's boiling the water. We see a color change going on and stuff. The salt is not a reactant, right? We didn't add a reactant to it. It's a single replacement reaction where you have aluminum and copper sulfate. The aluminum is replacing the copper in the compound. So this brown, nasty looking stuff here is just elemental copper. So if we lift this up, look at that, right? Nope, that's copper, right? So it's eating away at the aluminum foil. Hey, look at that. We can. So as opposed to what the other one's done. Oh, you know what? There's still some sodium chloride on this one. I wonder what would happen if we rinsed this one onto this one. Enough of it make it onto there?
Yeah.
Is it starting? Yep, there it is.
She's going.
Right, so if the sodium chloride's not a reactant and all that kind of stuff, we've got to think about what is going on there. I like this one, just the way that it
Just does it.
like eats it.
Eats it. It's eating it.
It's eating it. It's alive.
Don't write that it is eating the aluminum foil.
Well,
I told you what it's doing.
that one looks a little more red.
That's
You
good.
can see the
Yeah.
reddish from the copper a little bit more in that one. The other one looked a little bit more brown. Particle size and shape can affect color sometimes.
But it's rust.
It's not rust.
But in my single tube reaction lab I did at the very beginning of the year, it was rust.
Definitely wasn't rust then either. Right, so we can see that one and what's going on with D. So trying to go what's different between those two. Obviously, this one changed again after we added the residue from the first one to that second one.